So today we're going to introduce the 6 trig functions. This is like square one of trigonometry. I split them into 2 categories. I call them the primary trig functions and the reciprocal trig functions. So the first thing to know is that these are based off of a right triangle. Behind all trigonometry, you have this idea of a right triangle. So I'm going to make a right triangle. So there's the right angle. And we have 3 sides and 3 angles, of course. And there's an important side called the hypotenuse, right? So here's the hypotenuse, and then we have 2 legs, and we have the right angle, and we have 2 sides. All right, so we have to start naming things. So I'm going to name an angle. I'm going to name both of these angles. Let's call this angle theta. And let's call this angle, let's call it beta, which is a capital B with kind of a tail on it. All right, so this is the hypotenuse. And these, you name them depending on what angle you're looking from. So a lot of times, this doesn't go with these notes. I see people say stuff like this, sine equals 0.7. Well, that's about as meaningful as square root equals 0.35. You cannot, you have to have an angle there, like sine of 25 degrees equals something. Or cosine of 17 degrees equals something, or the tangent of 132 degrees equals something. You have to have an angle here. If you don't have an angle there, that's the same thing as having like a square root symbol without anything inside. This is not sine times 25 degrees, it's sine of 25 degrees. You have to take the sine of an angle. If I have the sine of 25, it equals a certain number. If I have the sine of 10 degrees, it's a different number. If I have the sine of 5 degrees, it's a different number. You can't just say sine. What angle are you talking about that you're doing the sine to? So I know that's kind of a weird thing, but that is very important. Now, having said that, we have 2 other names, which I'm going to just write them up here. Opposite and adjacent, which I'll abbreviate OPP and ADJ, and you are welcome to also. Now, at first people get confused because they think, well, which one's the opposite, which one's the adjacent? And it depends. If I'm looking from theta, then this is the opposite side, and this is the adjacent. This is opposite to theta, and this is adjacent or touching theta. The hypotenuse is the same either way. So if I'm looking from theta, that's how I would name them. If I'm looking from beta, this side is opposite beta, and this side is adjacent to beta. See, so you can't just pick a side and call it opposite and you're good no matter what. You have to pay attention to the angle, and the angle is part of the trig function. So now I'm going to write these down, and let's look at something with numbers in it so we can see where this is going. All right, so put that on the side. We know it has to do with the right angle. We'll talk more about that. What are the trig functions? Sine, I want to use a different color here. Sine of an angle is the opposite side over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. And the tangent of an angle is the opposite over adjacent. Now these you must memorize. These are like your times tables. If you're going to go on in math, knowing the trig functions, their definition is bedrock, foundational, square one stuff that you have to know. So you need to memorize these. You may have heard of a mnemonic device, SOHCAHTOA. The thing is, you can't learn this by the sounds, SOHCAHTOA. It only makes sense if you look at the letters, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's only useful if you actually spell it out. If it helps, use it. But one way or another, you've got to know these trig functions. All right, then we got the reciprocals. So the obvious one, tangent, its reciprocal is cotangent. And it's literally the reciprocal of that. Now these are unfortunate because you got to switch letters. This is the cosecant. And this is the secant. Right? Everybody wants the S to go with the S and the C to go with the C, but that's unfortunately not true. So the sine goes with the cosecant, the cosine goes with the secant. You got to switch letters there. And notice they are literally reciprocals. For me personally, instead of memorizing 6 things, I memorize these things and I know which one is the reciprocal of the other, right? So if I know sine is opposite over hypotenuse, then its reciprocal cosecant must be hypotenuse over opposite. I just memorize it that way. All right, so you need this information. I need to erase to write more stuff on the board. And what I'll do is I'll erase this. I'll write this smaller. I'll erase it all and write it all in one column. And I want to look at a triangle with numbers, so this makes a little more sense, hopefully. All right, so if I just list all 6 of these, we had sine opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent opposite over adjacent, and here come the reciprocals. Cosecant, flip that over, secant, flip this over, and the obvious one, cotangent, flip this over. All right, so let me give you a couple triangles. Well, let's just start with one. Got to be a right triangle. And let's do the classic 3, 4, 5 right triangle. 3, 4, 5. Remember, the Pythagorean theorem has to work here. And now I'm going to name these angles. Let's use theta and beta, like we did there. So the only difference is I have numbers in the triangle now. All right, so watch how this plays out. If I ask you what is the sine of theta, you would think in your head opposite over hypotenuse. Now the hypotenuse is obvious, or should be. The hypotenuse is always across from the right angle. It's always the largest number, right? So I know for sure that's over 5. The question is, which one's the opposite? Well, where are you looking from? See why it's important to have something there? If you look from theta, the side opposite theta would be 3. Right? So there's my first trig problem. However, if I asked you what is the sine of beta, see, especially at first, people just pay attention to the sign like that's all that matters, and this is some meaningless detail, but watch the difference that it makes. I know sine is always opposite over hypotenuse, and I know that is the hypotenuse. The question is, what the heck is this opposite? Well, if you look from beta, the opposite side would be 4. See, this is the same triangle. It's the same trig function with 2 different answers. Why? Because of that angle. That angle is hugely important, and the biggest mistake people make at first is they ignore that and focus on these first 3 letters, which you got to focus on both. All right, so basically I can ask you any trig function looking from any angle. So let's say I go, what is sine beta? What is cosine theta? What is tangent theta? What is cotangent beta? How about secant beta and cosecant theta? Right, so we're doing them all and switching up the letters. So the first thing I got to know is what they are. Sine is opposite over hypotenuse. Cosine is adjacent over, so you're going nowhere if you don't know that. Tangent, opposite over adjacent. Let's just start with those. All right, sine is opposite, they're all fractions. They're all fractions. Hypotenuse is fixed. Everywhere I see a hypotenuse, I can put that in. Here, we'll do it this way. So the opposite is where you got to be careful. Looking from beta, the opposite side would be 4. All right, how about cosine theta? If I look from theta, that would be opposite. That's already covered as hypotenuse. This one's got to be adjacent. And by the way, adjacent means touching. So if you already ruled out the hypotenuse, actually adjacent means next to. You can think of it as touching. Right, if this is theta, that one's already accounted for. That's got to be the adjacent. Tangent of what angle? Theta is opposite over adjacent. All right, what is cotangent? Well, that's this flipped over. Adjacent over opposite. Secant is cosine flipped over. Hypotenuse over adjacent. Cosecant is sine flipped over. Hypotenuse over opposite. All right, everywhere there's a hypotenuse, I know it's 5. So this is going to be, let's see, from beta, adjacent, it's touching it next to it, but not the so that's 3. And opposite of beta would be 4. These are kind of running together, aren't they? Secant is hypotenuse over adjacent. So where am I looking from? Beta. Attached to or next to or touching beta would be 3. So there's that one. Cosecant theta is hypotenuse over opposite, and I'm looking at opposite of theta. So that would be 3. Right? So don't make assumptions. It is what I'm showing you. You have to pay attention to what trig function, because you got to know these definitions. You also have to pay attention to which angle you're looking from. And it's helpful to label the hypotenuse right out of the gate because that never changes. All right, so that's basic trig right there, like the first steps. Now I'm going to show you how the book asks you questions because they're kind of weird. All right, so I'm going to erase this. There it is for a minute if you want to pause it. All right, so in the book, you'll see a question like this. Let's do this one. And you know, nobody reads directions, so there's a whole bunch of directions above it. And basically, it says, sketch the angle in standard position. Well, it says, so you got it, here. Let me and you got to find all 6 trig functions. So you'll see when you read the instructions, but it gives you a point, and I want you to find all 6 trig functions from, here I'll show you, sine, cosine. Here, actually, you know how I would set up your work? I would set it up like this: 1, 3, 5, 7, 9. Sine, cosine, tangent, cosecant, secant, cotangent. And then you can just put the answer right in that spot, right? Instead of writing sine out for every problem, you could just do it in a grid like this if you want. Okay, so, and technically this would be of theta. Now the idea is you got to draw the picture based on just this one point, so there's a lot of like baggage here. So this is how you do your homework, so mark this spot on your, like, for the time slot. So here's an axis. We have, you don't got to worry about scaling, just try to do it kind of like accurately. So let's say this is minus 15 out. Well, if that's 15, this would be about half that distance up, right? So this would be minus 15, 8. Now what you're supposed to do is, the other point is understood to be the origin. It kind of talks about the directions. So you're going to shoot out directly from the origin to the point you just plotted. And then you're going to drop a perpendicular to the x-axis, right? So real quickly, there's 4 possibilities. They give you a point here, 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 or here, right? In any of the 4 quadrants. So for each one, you're going to shoot out from the origin. And then you're going to drop a perpendicular to the x-axis. See how that looks? You're always going to the x, not the y, never the y, always to the x-axis. Could be up or down. You're always going to the x-axis. So in this case, I dropped down to get to the x-axis. Now think about this coordinates. You got to think about it a little differently than you might usually. See this minus 15? Doesn't that mean that that's minus 15 back here? So I'm going to put minus 15. That is the length of this side. That's what that means. And so basically, if it's forward, it's positive 15. If it's backwards, it's negative 15. If it's up, it's positive 8. If it's down, it's negative 8. So even though these are distances, and you've gotten used to ignoring signs when it's a side of a triangle, for the trig, you've got to keep the signs intact. If that's behind the origin, you need to see a minus 15. How high is this? Well, it's 8 units up. So really, this is what we want to do with those numbers. So I have a minus 15 and an 8. Notice you have a missing side. So in every one of these problems, you got to use the Pythagorean theorem. So to find the hypotenuse, I have 8 squared plus minus 15 squared equals hypotenuse squared. So I'm going to solve that really quickly. And you can just round to the hundredths place. All right, this particular problem, it works out, no, that's not right. 64 plus 225. Yeah, this does work out. So H is 17. Now, some of yours, probably most of them, are going to be working out to be decimals, so 2 decimal places. And by the way, when you have a fraction, let's say you won't in this one, but let's say you get opposite as 3 and hypotenuse is 6. If you can reduce it, you should always reduce it. If you don't reduce your fractions, I'll take off a quarter point. All right, but let's get back to our main problem. You are going to, 1, plot the point. 2, connect origin to point. 3, drop a perpendicular to the x-axis. 4, calculate the hypotenuse. 5, answer the questions. And let's put in parentheses, reduce if possible. Now the answers in the back of the book might use radicals. Because we're doing this remotely, just do decimal and just leave the decimal in the fraction. That's fine. All right, so here we go. We're doing problem number 1, and I'm going to find all of these things. So sine, theta. Theta is at the origin. So for every one of these problems, theta, the right angle is obvious. Theta is not the one out here in space. Theta is the one right here attached to the origin. So for all the problems, after you draw your triangle, theta is the angle right there at the origin, inside. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Now you can look at these and do the same thinking, but this is how I do this, the rest of it. Cosecant is which one flipped over? Sine, so flip it over. Secant is which one flipped over? Cosine, so flip it over. And this is tangent flipped over. Right? That's what I mean. It's easier if you just remember the main three and which one's the reciprocal of which. Let's try one more. That's not really your first problem in your homework. That might be a little small for you to see. So let me do another one where I actually list them out. You can do this too if you prefer. I'm just trying to make your life easier on the homework. Right? Otherwise, you got to do this like every time. So let's start over here. How about I give you the point 4 comma minus 6. That one will have decimals. So the first thing I do, plot the point. 4 minus 6. Connect the origin to the point. Drop a perpendicular. Well, this isn't quite dropping, but we're going to the x-axis. You know, I'm going to make that bigger. 4 minus 6. Right? Theta is always the angle inside the triangle connected to the origin. And what do I know? I know I went forward 4 and I went down 6. That's a slightly different way of thinking a coordinate than we usually do. What's that missing side? Pythagorean theorem. 4 squared plus minus 6 squared equals h squared. I'll do the button pushing. Oops, yeah, 16 plus 36 to the 0.5. I'm getting 7.21. All right, this is going to be really bad form at first, but for now, because we're remote, we're just going to leave that as a decimal. Ordinarily, we do this as a root. We're ready to go. Sine of theta is opposite over hypotenuse. Now, your answer won't match the back of the book because this would be a radical. Well, let's just stick with this for now. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That can be reduced, and it should. If you leave this as your answer, I'm going to give you most of the credit, but I'll take off a quarter point. Cosecant is the sine flipped over. Secant is the cosine flipped over. And tangent, or cotangent, is the tangent flipped over. And there it is. So I want you to try some of these and let me know if you have questions, and we'll move on from there. Have a great day.